Advent of Code 2024, day 18, RAM run. This is OXDF. Let's take a look. So basically, we're going to get a long list of pairs of XY coordinates. So column row, gotta remember that. And basically, we're going to have a 71 by 71 space. It goes from 0, 0 to 70, 70, so inclusive. And we're going to use 6, 6 in this example for the example input, so smaller. And basically, they're implying that these blocks are coming in over time. So for part 1, I'm supposed to say after the first 12 blocks have fallen, the grid will look like this. Can I find a path from the 0, 0 to 6, 6? And so the case is that there's an answer, and they want to know the minimum number of steps to get through the maze. So in the big thing is some percentage, some part of our list is filled in. How do we find a path from the top left to the bottom right? What's the minimum number of steps? This seems like very straightforward breadth first search. So let's go take a look. I'll do gen day for day. I can't believe it's already day 18. And we will take a look. I should grab the example input here and go to my example.txt and paste that in. And then we'll close you. Let's see, what does our input look like? All numbers, and we have 3,450 of them. Not huge, but it's not small. Well, it's not very manageable. All right, so we need to think about how we're going to store these. I guess we can read in lines, and then we can say blocks equals. Can I do this all in one? Line for line in lines. We need to parse each line is going to be a split the line on comma. I don't know why I did it that way. That's a very weird way to do it. Line dot split comma, and then that's going to result with two numbers, which we can, I guess, list map int onto. Actually, let's tuple, not list. Wonder if I can. Yeah, okay, we'll go with that. There's a part of me that wants to make it like so. If we do this right now, let's see, blocks. We do this. I believe we're gonna have what we want. Python, say there example. There's a part of me, I just like working row column instead of XY. So there's a part of me that wants to flip this. I wonder if I don't think we can do this, but oops. Like, could I do this like that? Will I get? No, you can't. Where am I? I may seem to have messed up parenthesis in here somewhere. Control Z. Okay, so we're back to what's working. Almost back to what's working. Almost back to what's working. Okay, and now the question is, can I boom, boom, boom like that? I don't think the answer is yes, but oh, we can. Okay, so beautiful. So I'm going to get now I have row column instead of column row. I don't know, that just makes me happy. At the top here, we can say if this dot arg v1 equals input dot text, then what's our num rows equals 71, num calls equals 71, and num part 1 num equals 1024, else num rows is equal to 12, I believe, 13. I better check this. Let's see, I get that right. 0 to 71, 6. 0 to 6, so it'll be 7. Num calls equals 7, and part 1 num is equal to, and how many do we drop? After the first 12, like 12. Okay, so now we have our separate. Now we have our based on our input, we have our setup, our size going correctly. we have our input read in and read into a blocks thing. So now we need to say, let's do a breadth first search. So we're gonna need a queue from collections import deck. We will start our queue equals deck of, and what is our state going to look like? It's going to be the position, and we want to keep the count, I guess, along the way. So it'll be our R, C, C, and 0. I don't know why it's RC. We're going to start at 0, 0, 0. We can do state equals R column distance. All right, so now we have that. We can do while Q RCD equals Q dot top left. We get our state. We want to check and see for next R, next C, next D, and then we'll do our thing. So the positions we can do will be next R would be R plus 1, C. Ooh, let's not do that. Let's do DR because I think this is, I don't know why, but this feels hard for me. For DRDC in, yeah, this is better. Our options are -1, 0. I really should like write a macro for this. 1, 0, 0, -1, and 0, 1. So for the options here, we'll say next R, next C equals R plus DR, C plus DC. If R 0 is less than or equal to next R is less than num rows, and 0 is less than or equal to next C is less than num calls. So now we're inbounds, and let's see. We want this point, next row, next column, not in blocks sub part 1 num, not block first that many. Oop, nope, let's do it this way. From the start to there, so that'll give us that. Then q dot append, and what is our state going to be? It's going to be next R, next C, and D plus 1. We need an end state. If R equals num rows minus 1 and C equals num calls minus 1, break. I guess we're done. And then part 1 is going to be D. I mean, let's give this a try here. This is taking longer than it should, so something is not quite right. Oh, we are not tracking scene. We're going in loops. Okay. Scene equals set 0, 0. I think that works. I don't know why that looks weird to me. And so here we go. If R comma C in scene, continue, and then otherwise scene dot add R comma C. That went much faster. 22, and 22 is correct. 382. Boom. All right, let's read part 2. All right, so for part 2, we're asked to look down the list. So we have this list of like 3,000 something blockers that are falling into place. And we basically picked a point halfway through and calculated what the shortest path was. What we now need to do is we need to figure out at what point, if we keep putting the blockers in one by one, at what point is there no path left? So in this example, there's a path here that's the O's, but if you put one at this top right corner here down one row, now there's no paths left. And so the question is, what is the first point where there's no paths left? What is the coordinate of the block put in that causes that to be the case? And that's it. So here we found, we don't care about the distance anymore. We now need to find we need to do really we want to check like over and over again. And this runs in 0.2 seconds. We can run a couple more times, you know, 0.2. But if we do 0.2 times, what do we have here? 3,000. Just say 3,000 times 0.2 is 600 seconds. It's going to take 10 minutes. I don't want to wait 10 minutes. But we don't have to, because we can do, if we get, let's say we know that row 1000 is blocked. Well, then we know row that 1001 is also blocked, 1002 is also blocked all the way to the end. So we don't have to check every row. We can check halfway through. And then if it's blocked, we can ignore all the ones beyond it. And then we can go halfway again and halfway again. That's called a binary search. And binary search is going to converge really quickly, because like 3,000, it's basically, we can do it in like 7 or 8 runs. And now we're talking a second, right? So we can calculate that actually. It's 2 to the, we're going to cut it in half each time. So it's going to be what power of 2 is there. So 1024 is 2 to the 10th. So we're looking at like 2 to the 12th. So like 12 runs at worst to get it. So that, again, that's pretty good. All right, so to do this, first thing we're gonna do is convert this into a function. So we'll refactor part 1. Def count steps takes in a num blocks. There's an int, and it's going to return an int. I can have it return none if it's blocked, but I'm just gonna return like 0 or -1. So now num blocks is what we're counting up to here. That's gonna go down here. If we find the endpoint, we will return D. And if we don't, so we exhaust the whole queue and we can't move any further and we've never got to the endpoint, we will return, I'm just gonna say 0. Let's return -1, it's just cleaner. So now we can come down here and we can say count steps part 1 num, which we set up here. And now in theory, we should still get 382. We do. So all we've done is converted that to a function. We can check it for our example, make sure it's still 22. Okay. So now we'll do our binary search. So all we need to do is we'll say like low, high equals 0 and len of blocks -1. So basically this is the range of potentially still good. So right now, everything potentially could still get through. So we'll say while low is less than high, because if they get to be equal, that means we found the spot. Mid is equal to low plus high divided by 2. So we'll get their average. Then we can say if count steps is equal, count steps of mid, mid or mid plus 1. Let's think about this. I'm gonna come back. We're gonna do some boundary checking in a second. I'm just gonna write this out at a high level. Mid, if that is not equal -1, which as in we found a path, then low is going to equal mid. Again, I need to check these boundaries. Else high equals mid. And then all we need to do here, so let's think about this. Okay, let's say our low and high, it doesn't really matter. If we do our low and high, let's say it's 5 and 6. We get to the point where we're down to just last 2 spots that both could be good. What we want to check, in that case, we want to check, let's say we check 6. So that would be, we check mid plus 1, because 5 plus 6 is 11, divided by 2 is 5. We want to get mid. If we had 6 and 7, it would be the same. 6 plus 7 is 13, divided by 2 is 12. Check the high, we get that. So we check mid. If mid is not -1, as in it has we got there, then low is going to be mid plus 1. If mid is -1, then high is going to be the last possible good one, which is just mid. So that'll look right. So at this point now, when low equals high, we will do, what do we need to get? We need to get the coordinate blocks of low. Let's see if that looks like that's correct, except for we got to remember, because I'm doing row column because I'm just being silly that way, or that's just the way I like to do it. So we need to reverse it back and get 6,1. We also want to get rid of these parentheses and stuff. So what we can do, can we just do that? No, let's see. Print, can I do part 2 star here? No. I guess we can do bang bang or bang comma bang dot join. around that. I think that might work. I don't like this. We're gonna fix it. I'm curious to see if it works. It doesn't because we have the single quote here and the single quotes here. So let's make this a double quote. And double quote. I think that should work now. Oh, but we have integers, not that. How annoying. Okay, so we're gonna have part 2 is going to be who'd have thought formatting the answer would cause me so much trouble. Dot join f or string x for x in. Someone's gonna leave me a comment. I'm sure there's got to be better ways to do this. But now we can just do part 2 like that. 6,1 and okay, so less than a second to get 636. Let's see if it's right. Boom. I didn't think this one was very hard at all. It was kind of fun though. I like the binary search. Yeah. Hopefully this all makes sense and you were able to follow it. Thanks for hanging out with me today, and I'll be back tomorrow.